Hello everyone. So welcome to my channel. So today we are going to do Leetcode question distinct subsequences. So today is the third day for the DP series. So here's the third question in front of you. So basically you need to first figure out that this question is similar to which sort of question, and then we'll proceed with the same. So first let's check out and check for the explanation of the question at later moment. First read out this question. So for that part, given two strings s and t, return the number of distinct subsequences of s which equals to t. So this is the line, but somehow let us know about that. What sort of question is it? That two strings are given and we are required to return the subsequences, number of distinct subsequences of s which is equals to t. So somehow we are required to check out for the similarity. And now next thing is a string subsequence is a new string formed from original string by deleting some, can be none, of characters without disturbing the remaining characters' relative position. That is, ACE is a subsequence of ABCDE while AEC is not. So here the thing is that in this question we are required to return the distinct number of subsequences which could be formed, and these subsequences should be equal to t, which is given to us as the second string. So this is the thing, is basically a pattern matching sort of question is this. But another thing is that earlier also we had done with the DP question which was similar to it. So just think about this, that which type of DP question is it, in which we are required to match two words, and then after that we are required to go ahead while comparing each of them with each other and so on. So yeah, this question is basically the variation of LCS, the longest common subsequence. And here we are not required to return a longest common subsequence, but here we are required to return distinct subsequences. Here the commonality part is basically on the basis of t, which should be equal to the subsequence which we will choose from S. So that's the thing which is here. So now let us check. Next thing is about the test constraints. So our constraint here is that S and T are basically up to 1000 only, and there will be at least minimum one character in a string. So now let us check for the first test case, which is here. So here we are given this rabbit and rabbit, and how we can form this particular, that is the thing which is given to us. So here you can see that if we write this rabbit, so we can figure out that this particular green means all these greens figure out with this rabbit similarity. So that is means the green portion is the first one, then the pink portion which is there means RA, and then B, and then skipping this B and then taking the other B, and then I, and then T. So this is the second, and the blue one, that is the third one, that is taking all till A, then skipping first B, and then taking both the B and then I and T. So this is how we are able to figure out three ways in which we can form this rabbit. So basically there are three subsequences which are basically equals to RT, means that is this one, and this is our S. So now here you just figured out that how we are doing this. The way we were doing it LCS, that we were choosing or not choosing. And here the thing is that if there is a match, then only we will proceed with the present word, or we can also choose to not to proceed with the present word. You can simply see in this triple V case that we are doing two things. Either we are choosing this B or we are not choosing this B. So this criteria is only valid on that particular scenario, then there is a match. And here you can see that in this example everything is a match. So here you got the example for matching conditions. Now let us take one more example in which there won't be any match. So 1 minute, let me show you. Let's check that if this second, yeah, in this second actually there is the case. You can see that in this particular bag we no, this also, okay, let us consider this also. So in this particular, we can see this B and A, right? This, and then we got at Z. So now we got one match. So now next we check for the another iteration, and then we check again B at A. Then we are required to figure out with one more Z, right? So we just figure out with this one, and then we now skip that A and we just took this B, and then now figure out with AG again. So now we have done with these three. Now comes the next part, that these three are now figured out. So now we are checking for a new B. So here we got the B and here we got A and G, new ones, and this one is also done. Now we are required with some new sort of which was not chosen. So this was as a whole not chosen. So here, when there is a match, then we are basically figuring it out that do we need to choose it or not to choose it. That's the thing. And if there is no match, then we will directly move ahead. So let us take arbitrary example by ourselves. If there is a word, take commander, even if spelling mistake is there, then just discard that. And word is command. So we are required to check that this command, how many subsequences we can form here. So one is the direct this one, right? And the other one, if we want to figure out, then surely we won't be able to, because when we check for other this A and R, right, then this criteria there is no match. So we will directly skip these two words, right? So here we will skip these two words and we won't move anywhere in this particular word, in this word, but we will move only in this word. So that is the thing which I am trying to convey, that when there is a mismatch, then in that criteria we don't want to do anything. But when there is a match, then it's our choice that do we want to choose this particular or do we want to skip this particular. So that is the scenario. So according to this only, in this question, either we are required to choose or not to choose in that criteria when there is a match, and when there is no match, then in that criteria we will just skip our word in the S string and we won't be doing anything for the T string, because we can only proceed with our T string when we are able to figure out that there is a match. So this is the whole criteria we would be doing in this. Now comes the part that, okay, now we are able to figure out that what options we are having. Now comes the part that in this options also, how we will figure out that when we are required to stop. So you can clearly see that if there is a case see if there is a word cat and there is a word catalog, okay, and basically this is S and this is T, if this is the criteria, right? So you can see that this S which is there, this S is basically smaller than this T, and you can say that yeah, there would be a match at this particular moment of time, right? So at this moment of time, you will be able to figure out that yes, there was a match. So here when this S is being exhausted, right? But still in this T, we are having some words which are being left. So in this criteria, because there was a match, right? So that's why we'll directly return 1 here. That is the thing. But if there is a criteria that means catalog was there, but let us take another example. So the thing which is here is, see, when we were taking S equals to cat and T equals to catalog, right? And we were saying that yeah, we got this thing, but this is another way we can say that it is reverse one. Here even if it is a match, but this is not which we are required to find. We are required to find basically a subsequence which is equal to T, not equal to S. So that is the thing. At this point we are required to write a base case, and in that base case the thing would be, something like this. That is S means, let us say its length is N and this length is M, right? So if N is less than M, means this case is there, right, which is in front of us. Or if another way around is N is less than 0, if any of these criteria is there, then we are directly required to return 0, because in that criteria, if S is completely exhausted, right, or if S is basically less than T, then we can't be able to figure out with a subsequence which would be equal to T. It is mandatory that T should be smaller than S. Else, how you can say that T is equal to any particular of S, right? So this is one of the things which is required. Now next thing which I was saying, that if S is now catalog, right, and T is equal to cat. Now if this is the criteria, then in that sense we will be returning 1. Why we would be returning 1 in this criteria? Because here cat, that is at T, is equal to a particular portion of S, although S is still remaining there, but T is now basically found a match in S, right? And now it becomes equals to -1 because now there is nothing left in the indexing part. So that's why there it will return 1, and that's why now we would be returning 1 because surely there would be a match. That's why T got exhausted, else T wouldn't have been exhausted, because we are taking a criteria in such a manner that if there is a mismatch, then we won't be moving ahead in our T. But if there is a match, then only either we will move or we will not move in the T. So that's why according to that only we are required to write this particular case. So does this make sense? Because you can clearly see that at S equals to cat and T equals to catalog, here you can clearly see that there is nothing when we can match it. But when S equals to catalog but T equals to cat, here we can directly match our T with our catalog, right? So this is the thing we would be doing here. Now comes the part that, okay, these are the things, options are there and so on, but for which purpose are we doing all these? These are for figuring out all the things which we can, means all the things which we can write in the same. I mean all the cases which could be generated for all that criteria. It means from every option which we can choose, means every character we will be checking and everything we would be going ahead with, right? So there would be a lot of cases, lot of permutations, combination and so on things would be made in this case. So that's why this particular question is basically a question for recursion. And because as per the constraints, then we would be going ahead. So we would be required to memoize this particular solution, else our recursive exponential solution won't work. So now let us go through the more explanation of our recursion part, that how we would be moving ahead with the same. So here I explained you about the same. Now comes the that what this question is about, that we are required to return distinct sequences of S equal to T similar to LCS, because in that also we were inserting or deleted. So either we are required to choose it or not choose it. The only difference here is that if there is a match, then only we have option to choose it or not choose it. But if it is a mismatch, then we'll surely not choose it. So that's the thing which is here. So this was the thing which I was discussing earlier with you. So before coming up with these things, we are required to write a recurrence relation, and that is that if both of them is a match, the way I was explaining in these examples, then we would be directly doing by DFS of n-1, m-1, where n simply represents the size of string S and m simply represents the size of string T. So here the thing is that we are choosing it and thus moving ahead, and here the thing is that we are not choosing it, that's why we are staying at the same. Else if there is a mismatch, right, so we will only move ahead with the string S and not with the string T. That's why we are writing like this. We need to move ahead in our string S on a mismatch just because of the fact, because if it is a mismatch, then we surely need to check that is other character in that S being a match with our T. So that's why we would be only moving in our S. So this is the only tweak which makes it different from LCS, but although we are doing the same thing only of choosing and non-choosing over a match or a mismatch. So this was about its recurrence, relation, options are, I already told you what the options are, and the base cases, I already explained that how the base cases we come up with, and these are the two base cases which we are required to write in the solution. So I think you would be now pretty much sure that how you are required to write this recurrence, relation, and then base cases means complete recursive solution. So now comes the part that after this recursive solution, how we are required to memorize it. So you can clearly see that here we are required with n-1, m-1. So this completely reflects that we are required with a 2D data structure so that we could memorize it properly. So according to that only, we would be choosing a data structure in which first we will be initializing with -1, and then after that we will be storing our results. Basically, we would be storing our result dp of I, dp of j equals to this particular, and then here dp of I, dp of j is equal to this particular, and we would be returning at this particular point. That is the thing which we will do, and at the end also we will be returning our dp of ij which would be there. So this is how we would be memorizing this particular question, and in the base case also, rather than directly returning 1, we would be returning by dp of ij equals to 1, and here also dp of ij equals to 0. So this is how we will be memorizing this question. I will show you the whole code about the same. Means this is the overview which I am giving you so that you could by yourself code it, and even if you get stuck, then you will analyze it and completely check that how it is required. Now let us come to its bottom-up approach. The thing is, the bottom-up approach is something like that. In this recurrence relation which all we were choosing, we just need to get this particular function itself, means this particular function which we are using, means all these recursive calls which we are using, we just need to transform this particular into a tabular form. That's the thing which we are required to do in our bottom-up DP. In bottom-up DP, we are required to come up with the state and a transition, right? So here the thing is that these two things which are there, they will be acting as a transition, and the state would be this particular thing which we were doing in our memorization part, and the base cases which are required to be covered. These base cases would be these which are there. So basically our base case would be now in a tabular form, and in a table only the first row and the first column, they will themselves be declared as if they are the base cases. See, here we can see that when m is less than 0, right? So at that moment only we are required to return 1. So what we can do in our table? In our table, what we will see is that we will make our first column completely as 1. That's the thing. And thus it will be acting as a base case. And in our first row, we will make everything as 0. So that will be acting as a base case when our n is basically less than m or n is less than 0. So this is how our base cases which were there in our recursive solution, they convert into a tabular format in our bottom-up DP. So let me show you that how we can form a bottom-up DP table. So here is the one I have already formed, so that means time is basically reduced while explaining. So now here is the thing is, as I already told, that we will make a first column as all 1 and first row as all 0. This is the thing which we will be doing, and this will be acting as a base case for a DP table. And you would have been noticing that we are having one extra row and extra column, right? And this is the reason we take one extra row and one extra column, so that we are easily able to come up with our DP solution. And the way we would be making our transition so that we could include our previous row or column just because of these base cases only, and we could directly come up to our answer which would be stored at this particular cell. So this is the thing which we would be using here. Now, as I already told, the state is basically dp of ij. That is our state, because we are required with two variable parts. One is for the string s and one is for the string t. And the transition is basically on the basis of that if-else condition only, that if there is a match, then our transition would be again on the two cases, but we are required to plus both of them. Else we will be just moving with our I only, and our j, it will be remaining the same in our this particular criteria, else criteria. Okay, so this was all about the explanation part. Now comes the part for time complexity and space complexity. So time complexity in both of the memoization and this bottom-up DP would be n into m, where n refers to the length of the string s and the t refers to the length of the string t, and the space complexity is also the same, that is n into m. But for the recursive part, the thing was, for recursion, it was 2 raised to power n plus m. Basically, it was exponential time complexity, but the space complexity, that was n plus m only. So that was the criteria for our recursion part. So now let me walk you through the code, that how we are required to code this particular question. So here is the coding part. I hope now coding part would be much clear after all this explanation. If still you have any doubt, then you could directly comment that down. I'll explain later. So here I've also commented the same so that it will become easy for you for seeing of this particular solution. So now it would be much clear. So here the first thing is, in this recursion part only, I'm thinking that's why I've taken this. Okay, actually that I was trying earlier only, that for memoizing it, but here in recursion this DP is not required. You can clearly see that I have not used that. So here in this particular recursion part, I will be returning this particular DFS function, and the thing is, I will be first taking this s and taking this t, and then s dot size minus 1 and t dot size minus 1, right? And basically why I am doing so is, here in this particular, I am here required to check for the fact that when my n and m basically at that particular criteria, just I am passing the sizes, and now here comes the part that choices itself, that if there is a match, then I will be going ahead with this particular function, that either I will choose or not choose, and I'll add up the result, that out of them which one is the maximum. That's the thing which I'm doing here, although I'm not taking that which is maximum or minimum, because here I'm required to get our distinct subsequences. So that's why after adding them up, means whatsoever result would be there in choosing or not choosing, that will get added up, and finally we will be able to get a final answer. And if we are not able to find a match, then we will just move ahead with that string s, and then that m would remain as it is, because we are not moving in a t. And here comes the part for our base cases. So first base case is basically when m is less than 0. So that simply represents that our t, which is required to be a complete match, then only we would be moving ahead. If it is less than 0, that simply means that we are required to return 1, surely, because there would have been match. That's why only it is exhausted. And in this second thing, if n is basically less than m, so that simply represents that our first string, that is s, was exhausted and we were unable to figure out with any match, or n is less than 0, that is all the same criteria only. So that's why at that moment we will return 0. So this was what we will be doing for recursion part. Now let me show you that how we are memoizing it. So for memoization part, let me just comment it again. So for memoization part, what we are doing here, we are taking this particular, I was at starting, I was checking that how we are required to memorize. That's why I had written that. Now the same thing as we were doing in the recursion part, and here we are resizing it with the +1 size. Here you can see whatever size of string s is there, we are just adding 1 to it, because now that will be acting for our base case itself, and at the starting only we are initializing our DP array with -1, so that this will act as a flag to us that if it is not equals to -1, then we will return that subcase. So that is the criteria here. So here if m is less than means these are the same base cases itself. Either we could return these base cases like this, or we could return these base cases by filling them into a TP of nm. That is the thing. So here as we are starting from the backward side, so that's why we are taking TP of nm rather than taking it as TP of ij. And also here also we are taking that as nm only. So that's why we have not written ij. Basically what I'm trying to say by ij or nm is that here we are going ahead from the last towards the 0th position. That's what I'm trying to figure out here. Not figure out, convey. So here if it is not equals to -1, then we would be returning that TP of nm directly. Else these are those cases only which were there in our recursion. Only thing is that we are filling directly to our DP here and then returning that straightforward. So this is how we are memoizing our recursive solution to means coming up with a top-down DP. So now comes the part for our bottom-up approach. So for bottom-up approach, here the thing is that here there was in some cases integer overflow, means there are some test cases which was there, although the constraints are in such a manner that they shouldn't be, but still it was getting. So for that fact only we have just declared this particular, so that after adding up these cases we'll do modulo for the same and we'll get our final answer. So here how we are doing is, again we are doing the same step which we were doing in our top down, but at that moment we were initializing with -1 because that was acting as a flag for getting us know that is there a subcase stored or not. But here why I have initialized with 0 is I'm basically doing that all at the one stroke itself, means our whole table would be now initialized with 0. Now comes the next part. This is that the first column of each row will be filled with 1, and this will be acting as a base case when m is basically less than 0. So that's why we are filling our DP table like this, and the whole table was already filled with 0 only, just because of this initialization part. So now comes the next part, that how we would be filling our whole table now. So yeah, now this is the thing which we are doing here. So for each row we are starting from 1 itself and going till equals to n, because now we have taken our rows are basically n plus 1 and n plus 1 size, basically means they are going till n plus 1 rows are there, and our columns are basically m plus 1, so that's why they are going till m plus 1. Now we are starting from 1 to m. Now here is the case that if both of them are equal, right, then what we would be doing is we'll add up them and we'll do modulo, and if it is a mismatch then we'll directly just move ahead with our I and just stop at that particular column of that particular character. That is the thing which we would be doing here, and at the end we will be returning our DP of nm. Why we are returning the endmost? The thing is that at this point either n would be exhausted or m would be exhausted, so that's why we are returning DP of nm, because either of them would be exhausted at that moment only we would be able to get out of the this particular, and then we will be able to return it. So this was all for this particular question. If you have any doubt you could directly comment that down. Yeah, and one more important thing, like as this particular channel is sponsored by Newton School, and even while means as per my all other groups in which I post all these videos. So the thing is, like, a lot of students just ask me about the question that they required a structured course for the placement preparation and so on. So that's why for that particular thing I just take a look at this course structure of the Newton School. So in that thing I just figured out that they are basically not taking any particular upfront fee. They are just concerned about your placement. They are providing the packages from 5 LPA to 40 LPA, And the thing is that they will be providing you one-on-one mentorship, a structured course would be there, your doubt solving sessions would be there, means everything would be there for your placement preparation. So I just find it out that it is a good thing to enroll. So that's why if you really like this particular course, whose link is basically in the description of this video, so you could directly enroll in the same, and you could find further details for the same in that particular link itself. And as there is no upfront fee, means you need to pay the fee only when you are get placed. So I feel like that this is something which you should try for the same if you are not able to get placed till now. So that is the thing for the same. So yeah, this was all, and thank you for watching.